All right, let's go take a look at Data Step. Now, Data Step is basically its own little programming language in and of itself. There's a lot you can do with Data Step, and it is unique in the business analytics space. There's not really an equivalent data processing um, language that R or Python or other languages have. To start a data statement or data step starts with the data, typically an out, right? So you're going to write out data set, an output data set. Um, you then define variables, so things like length. These are the variables that we're going to be creating. Now, SAS is a unique language in that it doesn't require you to strictly define the variables. If you define them in your code, it'll take the data type for the first assignment. Next, you can set, which basically reads a record at a time. Merge will take two or more data sets and merge them together. Modify will allow you to update and delete within a data step. Finally, the by statement is used for group by processing. So if you're familiar with SQL, it's kind of sort of like group by processing in SQL, but a little different. And then you use things like first dot, last dot, and then we'll see that in the examples. Finally, you can do normal formulas and expressions to modify data. You define loops to iterate over data. SAS supports things like arrays, so often you will load things into an array and then iterate over it. And then finally, SAS has its own way of doing conditional logic. So here, if variable 1 is greater than variable 2, then do something. SAS, you can read in the syntax, there's a couple different ways you can do greater than, less than, greater than or equal to. Let's go look a little deeper. How SAS processes data. This is what's unique. SAS reads a row at a time, and so it pulls that row into what's called a program data vector. And so in a set statement or a merge or modify, what SAS does is it will read each record sequentially and will do the processing of that record. So if you need to look back, you need to set what's called a retain, and you'll see that. We'll actually have a little exercise here at the end where you'll have a retain. Two other things that you need to know, SAS has a number of system variables. The underscore in underscore variable keeps track of the number of records that it's read into the input buffer, and that's often useful for controlling how you do processing. And then finally, user written variables. You can do things like daily return. Here's a simple moving average. Couple things to note. SAS is easy. There's only two variable types, numeric and character. Variable names can be up to 32 characters in length. Variable names can also have what's called a label if you want a more business-friendly label. I try to personally avoid that unless I'm doing something with building reports, just because you can now put spaces and other characters in the variable names. Um, the first character must begin with an English letter or an underscore. So you can't do like a hashtag. Subsequent characters can be English letters, numbers, or digits, but you can't use special characters. SAS variables are case insensitive, meaning if you have capital var1 is the same as lowercase var1. Variable lengths. Numeric variables can be 2 to 8 bytes in length. That's how much it is stored. Character variables can be up to 32,000 bytes in length. And then you can just simply define a variable or lots of variables by doing length statements, length, variable name, and the default storage. SAS is one of those languages where you don't need to explicitly define new variables, unlike sort of the lower level languages. Variable formats. So with just having two types of variables, SAS uses what's called a format to present the variable back to you. So we have things like character formats. So you can, if you want to change the look and feel of the variable without changing the underlying data, you put a format on top of it. So in this case, format name upcase will take a mixed case name or a lowercase name and upcase it without changing the underlying data. I don't typically use character formats. You may find them useful. I haven't. Numeric formats, on the other hand, I have found quite useful. And so there's literally dozens upon dozens of numeric display formats. Um, and so everything from decimals to percentages, dollar values, fractions, formulas, anything you might want to display as a number, you can use a format. Date format. Since SAS stores dates as numerics, people will say, well, where does it start, right? How does it do that? Well, day zero for SAS is January 1st, 1960. And everything since then is the number of days since day zero. So format date 9 dot. Date 9 dot, and you have to kind of go look up in the doc as to which of these formats, what the actual result will be, but it'll format things in the DDMONYYY. So date 9 dot will format the 26th of February 2018. You'll also note that 9, if you count up the numbers, 26, 1, 2, 3, 4, 5, 6, 7, 8, 9, that tells it how long the format is. And you'll see that over and over and over again. Data statement, probably the most common thing. 80% of the time we're reading in one or more data sets with the set statement, calculating something, and writing out more data sets. That's the majority design pattern. Copying and cloning data, there's proc copy, but almost everybody uses just a set and then writes it back out to another thing. You can read from one library and write to another library. Really powerful stuff there. Finally, modify, removes, replace, updates things. So when you need to update or change something within a data set, you do this with the modify statement. When you need to remove or replace, you simply write out remove or replace within the data set. Typically, you do this with conditional logic. So here, if var1 equals ABC, then remove a sample. Else do replace a sample. You can use Data Step also to restructure your file and rename things. So if I wanted to remove height and weight from a sample, I can just do drop equals on the output data set, and that will basically drop those two variables and not pull them into the new data set. If I just want to keep 3 variables, I use the keep statement, ID, body mass index, and weight. That will write those 3 variables out, and it will ignore the other variables. You can also rename variables. So if I need to rename sex to gender and DOB to birth date, I can do that. And I can do both of these rename and keep to control what I actually read into my buffer. So oftentimes this is like one of those performance things. So if I have a really extremely wide data set and I just need to take a couple columns off of it, I can restrict what I read in my set statement. I can also rename something to avoid name collisions on read. So here we have rename h equals height. Pretty straightforward. Okay, here we are back in SAS Studio. First thing I'm going to do is I'm going to pull in that North Carolina physicians data set, pull it into my system. Always go take a look at the log. We got 32,000 records. First thing I want to do, like anything, step 1 is to dedupe it. So I'll remove any duplicates. F3, look at the log. We removed 4 duplicate records. Let's go take a look at some interesting things. So remember that underscore in feature? What that allows me to do is allows me to get the first row of a data set. So let's hit F3, go look, and we now have the first row of that data set. Pretty useful. Here I set a special thing that says my variable that marks the end of my file equals EOF. If that equals 1, then I've reached the end of my output, and then I'm just going to output that record. Here we have Z. Next, let's go look at the by group processing. I think this is one of the things that is really useful and will be useful for some of our processing going forward. So first, let's go resort this data by provider type. Let's go zip over to provider. So here we have action, addiction, medicine, all other suppliers, allergy. And what we're going to want to do is identify the first group. So we want to identify unique set of provider types. Here we want to get the last group. So we're going to get a total number of physicians by provider type. And then we want to output the by groups. And so we'll have a running total of different physicians by provider type. So let's go look at what this looks like. First, let's go look at the log. Out of 32,000, the by groups data set has 32,000 observations. The first group has 88 and the last group has 88. Let's go look at this data. So the by group, you see I have a running total here. We have 2 addiction medicine providers in the state of North Carolina. All other suppliers, we have 15 of those classified. Allergy, we've got a number of allergy physicians. Wow, we got quite a few. Let's go look at the first group. So the very first record that we find for addiction medicine is this Bobby Kearney. And so what this gives me is the very first record of each of those groups. If I wanted to get the last group, I could actually ignore the last name, first name, so we'll do that. And we can see that in the state of North Carolina, there's 2 addiction medicine providers, there's 15 all other suppliers, 90 allergy and immunology providers, 205 ambulance service providers, etc. So this is a great way to create running totals and to calculate totals of data. Pretty useful for some of our processing going forward. Now you give it a try. Create a copy of week 1 data step, change proc import to be the Georgia version of the Medicare physicians, step through the code with the Georgia data set, and make sure that you got it running. With the last data step, change where the run total calculation is made. You can see how where you put that calculation makes a big difference in how the records are actually processed. What happens if you delete or comment out the retain statement? What is that actually doing? Take a look at that. You'll actually see that when it pulls that record into the program vector, if you don't retain specific variables, they don't get pulled into subsequent steps. How would you change the code to find the first physician by city? So instead of counting up things by physician type, look at them by city and see if you can change the code to find the last physician in the city and the total number of physicians by city. All right, good luck.